Hello, I'm Samuel Frade, PhD student at Faculty of Medicine of Porto University, and I'll be presenting the article OpenR Implementation Guide Towards Standard Low-Code Healthcare Systems. The authors are Thomas Bill of ARS Semantica and also part of OpenR International Board, Ricardo Correia of Virtual Care and also professor at the Faculty of Medicine, and myself. As a small introduction, as we all know, electronic health records have a positive impact in quality of care by improving the ability of healthcare professionals in enacting evidence-based knowledge management and also aiding in decision-making. To advance in those areas, it is imperative to gain the trust of the involved stakeholders, the doctors, medical professionals, patients, families, healthcare providers, regulators, as well as system developers and IT personnel. Even though two critical requirements are interoperability among the various systems involved and also the involvement of stakeholders, currently existing solutions are still vertical silos to a large extent and developed and maintained mostly by IT professionals. A way of achieving this interoperability and involvement is through standardization. In particular, the standard that we are proposing in this article is OpenR. OpenR is an open specification which describes the management, storage, retrieval, and exchange of health data in healthcare records. It's a model-driven development approach, and it consists of two main domains. One is the clinical domain, on which medical professionals and experts can develop archetypes and templates. And the other domain is the applicational domain, on which IT professionals will develop systems which are configurable by the templates done in the clinical domain. This approach allows the development of low-code platforms, which emphasize in visual interfaces to enable people, namely the healthcare professionals, without technological background, without the need to code themselves, can create and deploy business applications with relative ease. So basically, this is the idea of this study, which is to implement this OpenR-based low-code EHR system using available OpenR open source software components and following a model-driven architecture, aiming to investigate the feasibility and challenges of developing this system and presented it in as a step-to-step guide which can be reproduced. The methodology was basically looking at the architecture of the OpenR specification and splitting this in these two domains, and for which domain search for tools and components that support each step of the process to implement the system. For the results, we split them according to the domain. So for the model domain, the main artifacts produced were archetypes and templates, and the development process comprised of 5 steps. And for the first and the second step, it was used the Xmind to produce the mind maps, and on the second, the CKM to search for existing archetypes and templates. And for the remaining steps, it was the archetype designer, where you can create and edit archetypes and templates. So these steps consisted of collecting the data requirements. So basically talking with the clinical professionals and finding what data entries they would want, and the documents and all the clinical domain knowledge they wanted to put into the system. Then searching the clinical knowledge manager to find if these data entries that collected in the requirements existed already as an archetype. Then creating new ones or specializing the existing ones. Then creating the templates, which basically is like putting the archetypes together to create documents. And then finally, when everything is done and confirmed by the clinicians, we exported them in the operational template format. In the application domain, which was more workflow, a low-code development platform was developed in order to get this functional ecosystem able to generate applications that were based on the templates developed in the previous domain. During this development process, we mainly used 5 components or tools. The main one was EAJA Base, which is OpenR platform that implements the OpenR specification REST API. It also provides an SDK in Java, which we then had to implement our own integration in PHP, because one of the existing systems that we had to use is an obstetric system called OpsCare, and it provides user authentication, user interface, and a framework to build this ecosystem. We also used MIRT for other integrations outside the system. So MIRT is a good interface for setting this communication channels and general integration with several systems. The development process itself also was comprised in 5 steps. So the first one was the OpenR clinical data repository. So this was implemented using EAJA Base, as we've seen in the previous slide. Then it was the middleware development. So we had to build interface in PHP with the clinical repository. Then it was building the user interface form generation. So on this step, we actually had to develop our own, because there was no tool available within the OpenR open source available tools. Then for step 4 is basically generating the applications. So we had to develop some code, some generic code that each generated application would run on its own. And then for the final step, basic integration services, HL7 messages and some web services and database access with other systems. During this work, we found that the model development domain is very well supported with the tools that are available. But the options for the development components were a bit lacking, specifically in the user interface generation, which we had to develop our own. and also in the languages that are supported. So the SDKs and the code available was mainly developed using the Java language, which makes it a little bit harder for other implementers with using C, for example, or PHP, as in our case. We also found that it would be useful to have a new compact template definition in JSON, for example, to make it more approachable, and the parsing of this definition. We also found that this proposed guide and the developed system seems like a good solution, at least for small projects with a relatively small number of patients and users, or some initial open art projects, which allows to gain some experience, learn, and then you can also always upgrade to paid solutions. The limitations we had, mainly because of time, were more testing for scalability and stress tests. And for the future work, we are looking into implementing the OpenR task planning, which is a specification which allows process support and also decision support. And also to implement data analytics through a query builder interface, and building dashboards for data that the healthcare professionals want to look into more often, like for indicators and things like that. And to conclude, it was possible to use this the available open source components to create this low-code ecosystem that generates EHR systems itself. We found that there is a need for a visual interface builder tool within this open source community, and we hope that the simple step-by-step implementation guide proves useful to other developers and academia. Thank you all for watching our presentation. I hope you learned a little bit more. If you have any questions, feel free to contact us on these addresses. And best regards from Madeira Island.